Hello, you're welcome again to another video in our training series called Networking for the Layman. And so far, so good. We've taken like two or two so topics, and this is about the third topics we'll be talking about. And in this topic, we'll be talking about the IP addressing. Okay, we've talked about binary, we've talked about DNS. Let's talk about IP addressing. So, what are IP addresses? IP addresses, think of it like think of it as your identification in the digital world. How do I mean? When you go to sites like www. Say facebook.com, which is about one of the most popular sites in the world right now, you are actually going. No, let's say this is your system, you know, and this is me with my big head and my, yeah, if you see me before, I have a big stomach. Yeah. So this is me with my big head and my big stomach, and I type in www.facebook.com. What I'm actually doing is that I'm going on the internet to a web server somewhere. You know, on that web server sits the resource facebook.com. Facebook.com. Now, how does my system identify which resource it should go to on the internet? How does it identify facebook.com? How does it know? Why didn't it go to say msn.com? Or why didn't it go to say any other sites, say youtube.com? Why didn't it go to that place? Now that is the essence of IP addressing. So in the digital world, the IP address is like your house address. You know, someone comes to look for me, or somebody is looking for UBA headquarters. You know, it goes to 51 Marina Street, blah 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 blah. That is the address, number 51, on where Marina. Now you can see that the address is having compartments, is having parts. You know, there is the specific address of the house, there is the address of the street. Of course, you have Lagos. There is specific address for the, okay. Let me call it this way. There is a specific address for the neighborhood. Neighborhood, yes. Think of it like that. There's a specific address for the specific house. There's an address for the neighborhood. Of course, in the neighborhood there'll still be let's say 52. There'll be number 1 to 50 houses named number 1. I don't know how many houses are on that Marina Street. Maybe it's 500. Okay, it's a very pretty long street. Let's say it's 500 houses. So probably you have number 1 to 500. But UBA house is what? In number 51. So that is the same concept that IP address uses. Okay? So let's get into the meat of it. Now, I've taken a very broad overview of IP addressing in on the internet scale. Now let's look at it from your local network first before we go to the bigger picture. Okay, so going back to your local network. So on the local network, let's say we have, and interestingly, I missed my pen. Okay, let's say you have, let's see. Oh, before I even go there, let me quickly tell you that IP address, an example of an IP address. If I will give a definition to an IP address is a fourth octet address used for specifically identifying an object in a network. When I say object, it could be your phone, it could be your system, it could be your laptop, it could be a server. You know, when I say an object, it could be all those things. So it's a four octet address. For example, a classic example is let's say um, 192.168 dot, and I keep on missing the dots, dot 168.1.200. This is an example of IP address. It contains what? Four octets. This is an octet. An octet, remember from our binary days, an octet has 8 bits. That is 1 2 3 4 5 6 7 8 dot. I'm not saying this is specifically 192.168. I'm just giving you what it might look like in binary. 192.168 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot say 1 2 3 4 5 6 7 8. I'm just saying, for example, that may not be correct. So because we can have 255. So it has 8 octets. That means each octet has what? 8 bits. Each octet has 8 bits, either turned on or off in any combination, depending on the decimal number. So if I want to represent 192.168 in binary, in binary, yeah, I'll probably just convert 192.168 and 1 and the 200 into binary and represent them in binary, just like we did in our last class. So if we go back to uh okay, if we write it in binary, that's what we're going to look like. Just convert 192 to binary, convert 168 to binary, convert 1 to binary, convert 200 to binary. To save us time, I won't do that here. We've already done that in the binary class. You can go look at the video and get the hang of it. Okay, so let's say I was saying this is an example of an IP address. More often than not, an IP address is it has two versions. There is IP version 4, IP version 6. Okay, we won't go into the nitty gritty of version 6. Just that I will mention it here. This is basic overview. Now, if you want the full overview, I'm going to start a new series very soon for the CCNA class. I'm going to deal with IP addressing very, very in depth. You can take a look at that series, or you can contact me at the address below. I'll give you the address in my bio. You can send me a mail. You can register for the CCNA class. We'll go into the nitty gritty of IPv4 and IPv6. All right, but more often than not, going back to where I was, more often than not, IP address is combined with what we call a subnet mask. A subnet mask. Subnet mask. Okay, which looks like something like this. This is a class C IP address, so I'm going to use the class C subnet mask for it, which is 255.255.255.0. What does that mean? I'll tell you very soon. And apart from the subnet mask, it also uses what we call the default gate. Yeah, I told you my English is very bad. Default gateway. So the default gateway, which is the IP address of the router you're connected to, I'll tell you what that means. Let's say, for example, in this case, 192.168.1.1. In this case, all right. So what does all this thing mean? So I'll take a look at that now. 1 minute. Okay, I just did one magic right now. I have paused the video. I drawn this whole network out so that I won't take your time. Okay, so let's say, for example, this is me, the boo, me, the boo, and there's a bay somewhere here of my network. I've connected to a switch. I specifically wrote a switch there, and I have a bay somewhere that I need to communicate to. All right. Okay. Just for the purpose of this class, I'm going to assume I want to send a ping, not the BBM ping. I'm sending a ping to our address, which is 192.168.1.55. It looks like 155. It's 1.55. Don't get it twisted. It's 1.dot. Okay, 1.55. Now, I said a ping earlier on. Now, as a network person, the ping is one of your most trusted friends. It helps you test connectivity between points. Basically, a ping is just a string of 1 to 9 and A to Z. Just a pack of 1 0 1 2 3 4 5 6 7 8 9 0. Then A B C D E whatever, and packed into a packet and sent to your destination, uh, and then you get a reply, to test connectivity. So let's say, for example, I want to send a message from Boo to Bay on my network. So it goes blah, 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 blah. It has a source IP address of this. It has a destination IP address of what? Of this. So it checks. I am sending to 192.168.1.55. So how do I know how to get there? Do I need to get on to the router before I get out into the internet before I reach this bay here, or do I just send it straight on my local network? Now that is the essence of your subnet max connected on your configured on your network or your system. Subnet max, basically, let me just tell you what subnet max does. Subnet max tells you which part of the IP address is used for personal name, personal address, and which part of the IP address, the complete IP address, is used for uh, 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 neighborhood. If I can spell neighborhood, if that is correct, address. Basically, in engineering parlance, it says which part of it is used for the host addressing and which part of it is used for network addressing. Is this still confusing? Okay, now let me break it down a little bit. When you look at my old name, my name is Olufemi, and my surname is what? Bakari. You can see that my name has two parts, Olufemi and Bakari. That Olufemi is my host name, my host address. So if anybody enters my class and says Olufemi, probably if there were two of us, two Olufemis will stand up. Okay, let's assume it's only me in the class. Olufemi will stand up, which is me. But if the person comes in and says Olufemi Bakari, that means only me will stand up, right? Because it has my host name and my neighborhood address, right? It has my host address and my neighborhood address. Think of the same thing as the same thing that the subnet mark does. It specifies which part of the address, which octet of the address is used for network address and which part is used for what? Host. So therefore, it goes to say that if you have a 255, it's used for what? Network addressing. If you have a 0, it's used for what? Host addressing. So in this address, we have 3 octets for network addressing, right? Network, octet 1, octet 2, octet 3. So on the network, it has what? The specific address of what? 200. Oh, are you seeing the clearer picture? That means in this network, 192.168.1, this particular system is having the specific address of what? 200. So now it's sending a ping to 192.168.1.55. Yes, did I lost myself somewhere there? Yeah, I was talking about what's it called? Pings and all. Let me just show you what a ping. What if you're going to send a ping? What you definitely do? You launch your command prompt. You can go to once you launch command prompt, it comes in here and you probably type not probably, you definitely type ping, then the IP address you want to ping 192.168 dot. In this case, I'm sure I have 1.1. I know I have 1.2, and I know I have 1.3. So let's do a 1.3. I praise there. Yep. So let's later. My ping is dying. Also unreachable. So let me do the one I'm very sure of. I know I have a 1.1. So yeah, you can see that. So what it's doing is sending 32 bytes of data to that destination and is waiting for a reply. So it's more like a sonar. Dong! Then it's getting a reply. Dong! It's getting a reply. Dong! It's getting a reply. So it's waiting for that reply every moment it sends that data. It sends it how many? 4 times. Dong! It gets a reply. So if it gets a reply, you say something like this with it gets a reply every time it sends the ping. Okay, so that said, that is what the ping looks like. Excuse me. That's what the ping looks like. And so, having said that, yeah, okay, I spelled my name wrongly. It's not Bakar, it's Bakari with an E. Okay, so having done that, I'm sending a ping from boot to B to Bay. That's a B from boot to Bay, and I have opened up my command prompt. I've typed Bay's address 192.168.1.55, and I press enter. What actually happens is this: this computer looks. I have been configured with a subnet mask of 255.255.255.0. It looks at the destination IP address, which is 192.168.1.55, and says, okay, 192.168.1.55, looks at its subnet mask and says, okay, my first octet is used for network addressing. My destination first octet is also network addressing. So okay, I check it against my own. They are the same. It checks this and checks this. I say, oh, I have 168 here, and it too has 168 here. I check it. Okay, that's part of my network address. Okay, so first octet, second octet are the same. Checks the third octet as against its own subnet max, and says, oh, it's same. It has same third octet as mine, and all those 3 octets are used for network addressing. That means this person is on my network, right? Yes. So I will just go on the network and look for the person on my local network. That means this person is on what? On my network, is on the network I belong to, because my first 3 octets is used for network addressing, and the next person, the destination IP address also has the first 3 octets as the same as mine, and is used for what? Network addressing. That means we are what? On the same network, so it just sends it to it directly. I'm going to change my color here a little bit and choose a random color, and sends my data to him directly using a concept I'm not going to talk about in this video. It's going to be in the CCNA series, what we call ARP, Address Resolution Protocol. Works with our layer 2 addresses. Okay, layer 1, layer 2, what are those things? We'll talk about them in the CCNA series. All right, I've already gone deeper than expected in this series, but I want to explain as best as possible so that you understand. Okay, so I haven't done this. It now checks. Oh, sends to Bay, and Bay replies, okay, we are on the same we are on the same network. Okay, no sweat, no problem. All right, everybody is communicating quite all right. Even if I had a third server or system somewhere on the network and it's having the same IP address, the same network address. Of course, I've used the my subnet max to determine who I'm talking to. All right, so to determine if they are on my network or they are not on my network. Okay, so I told you earlier on, an IP address is combined with the subnet max, and more often than not combined with the router IP address. To the default gateway. I forgot to put an IP address for the router here, which is 192.168.1.1. All right, let's assume that is the router IP address for this interface I painted pink here. Okay, excuse me. Having done that, now let's go back to our previous example. www.facebook If you remember in our DNS series, when I told you um, about name resolution, if once you type in www.facebook.com, it tries to resolve it to an IP address, right? Yes. So let me just quickly show you that. If I do a ping www.facebook.com and you press enter, see what it first did. It first resolved the host name facebook.com to what? An IP address, which is a new one. Okay, it resolved it to an IP address here. If you look at my IP address, it's about the same. Maybe it's pinging to another server right now, but when I first did the ping, this was the address I got. Okay, if you look down here, if I can still find it, okay, I can't find it again. Good, great. I'm sure I have it somewhere. Yes, this is it. When I did my first ping facebook.com, I got this address. Pinging facebook.com, it first resolved it to an IP address because computers don't understand what facebook.com is. It has to check a registry, DNS record, for what is facebook.com. It now gives it an IP address. Oh, if you want to get to facebook.com, go to 173.52.252.120.68. So that is one of the IP addresses of facebook.com servers. So going back to our theory, the destination IP address in this case is going to be what? 173.252 173.252.120.68. So my computer now tries to ping 173.252. This is it checks in my network addressing range. My first octet is used for network addressing, right? Let me check what is in my first network. 192. It checks the destination first octet rather is 173. Red flag. Ping, 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 ping. Alarm everywhere. This guy is not on my network, right? Yes, he's not on my network. So what do I do? Who do I talk to? He's not connected to me directly, so I can app to get his MAC address. Oh yes, that was the concept I was pushing into the CCNA class. There is a layer 2 addressing. We'll talk about that in CCNA. So I can app for his MAC address to send data to his MAC address, right? All I can do is, okay, this guy is not on my network. I don't know how to reach it. I have to ask someone. And who do I ask? You guessed right. The router. It goes online on the network and says, okay, who is my router? Router. How do I get to 173.252.120.68? And yep, see, that's it. So it has a configured default gateway. 192.168.1.1. Let me show you. Right now, do as I do. Press the Windows button or go to Start menu and go to your control panel. Just go to control panel. On your control panel, you're going to see something like this. Let me drag it into the picture. And in your control panel, look for Network Sharing Center. So when you open up the Network Sharing Center, you'll see something like this. On that page, look for what we call change adapter setting. In your adapter setting, you are either using a Wi-Fi network or you are using an Ethernet cable. In my case, I'm using a Wi-Fi network. Right click on that network and go to its properties. In the properties, let me drag it into the picture well so that you can see it. In the properties, you'll see IPv4. This is TCP IP version 4. Of course, there's also version 6, which is here, but this is what we're talking about right now. Click on its properties, and yes, you won't see anything. Okay, that's if you're using auto assign. Okay, like in my case, where I'm going is this. Hold on a moment. Yeah, instead of going to proper, just double click on the connection. Double click on the connection so that it brings out the status. On the status, click on details. This is what you'll see. You'll see that it has a configured IP address of what? This. It has an IPv4 address of what? This. 1.4. This is 192.168.1.4. That's my system right now. And default, the subnet max is what? 255.255.255.0. That's how it's able to determine if it's trying to talk to a device on its own network or outside his network. If it's outside his network, it talks to who? The default gateway, which is configured 192.168.1.1. So anything, any destination, any device that doesn't know how to reach it, it sends it the data to who? The default gateway. This same information I just showed you right now, you can reach it just by going to your command prompt, type in CMD. When you press enter, when your command prompt comes up, you can do IP config. This is probably faster. IP config will show you the I'm using my wireless now, will show you the same information. Alright, I actually forgot before, so I just remembered. So it shows you my IPv4 address is what? 192.168.1.4. the subnet max is what? 255.255.0, and it's combined with what? A default gateway of 192.168.1.1. So after this guy red flags and determines that this destination is not on my network, what it does is it forwards the data to its router, the default gateway, which is the IP address of the router that it is connected to. It forwards it to this, and the router, being who he is or what it is, determines, okay, what is the best path to reach this network, and sends to this guy, and this guy of course sends back the reply through the internet to the router and gets back into the network. The router determines, oh, this data is meant for so and so, sends it to the switch determines, oh, I'm forwarding now this port to this guy. That is what happens when we communicate over the internet. You can see the complexity of all these things, how it goes on in split seconds. For example, a classic example again I'm going to give is yes, I've been on Facebook. Yeah, everybody Facebooks. So what I'm going to do is I'm going to go to a website I've not been to, and let's say www. Give me a website. What? Oh, let's go to go.com. Oh no, I've been to go.com. Let's go to ESPN. I'm a football lover, so let's go to ESPN.com and we'll press enter. Oh, you can see, if you can just see what is going on here at the bottom left, is trying to resolve ESPN.com into an IP address, and having gotten the IP address, it sends the request to its router, and after that it does with the blah blah blah, and there you have it. Serena Williams is battling Wu again. She's always battling somebody. Battle for Aussie Open title against Keba. Yeah, so you can see all the process we just explained right now. It checks the destination after first resolving it on IP address. It checks if it's on its own local network. If it's not, it now checks sends to the router via all the process that I've mentioned, ARP. Then gets the router's MAC address, so forward the data to the MAC address of the router. The router determines, okay, where is it going? Oh, it's going to ESPN.com. I don't know where it is, but I can ask someone to tell me where, who knows how to get there. It goes on and on and on and on like that in seconds. You won't even notice what happened. All right, so that is what goes on behind the scene. Beibu wants to communicate. They determine they are on the same LAN. Of course, when I say LAN, I mean local area network. That's what I mean by LAN, local area network. When I say LAN, they are on the same LAN, so they can communicate on the switch locally without having to go through the default gateway. All right. So, but if where you are communicating to is remotely on another one, is remotely across a one. One is wide area network, so that is one. So it has to go across the switch, across the router into the wide area network, which is basically what the internet is, and goes into where it goes. Now on the internet, you just find a connection of different networks, a router connected to each other. Different connections of router, different networks. This one is connected to this one is connected to that. That's what we call it internet work. Excuse me. Different routers, different networks connected to each other. So that's how we find our way round on the internet. So I'm going to talk about that mysterious cloud very soon. That's one of the series I've penned down. The cloud. That guy is very mysterious. We'll talk about that. I'll demystify it for you very, very soon. So, this is getting long enough. This is about 32 minutes already recorded, and I think I should pause here. This is going to be our IP address. Let me put it part 1. IP addressing part 1. I'm going to have a part 2 of IP address. That's where I'm going to what are the types of IP address we can have, classes of IP address we can have, what is private and public IP address, and how we can assign IP addresses. I hope this has been informative for you, and I'd like to thank you for viewing.